Good day, everyone, and very warm welcome. Thank you so much for joining us today for the CIB W120 Disasters and Built Environment Seminar Series. My name is Yashoda Kalutadege, and I am a doctoral researcher at the University of Newcastle in Australia. And also, I serve as the communications coordinator for the W120 Commission. So, it's my pleasure to host the today's seminar, and I want to thank the coordinators of the commission, Professor Temi and Dr. Krishanti, for their support and guidance in organizing this session. When it comes to today's topic, it feels really relevant and timely. Artificial intelligence has moved from being a futuristic concept into something actively shaping the many sectors today, including disaster risk management. But how does that AI potential translate into practice in disaster risk reduction? That's exactly what we'll exploring today. So the title of today's seminar is Integrating Artificial Intelligence into Disaster Risk Reduction, the Global Review and an Empirical Insights from Australia's Multi-Sector Adoption. So I'll quickly go through today's agenda. First, we'll begin with the acknowledgement of country. Then we'll move to the presentations by today's speaker, whom I'll introduce shortly. And after the presentation, we'll have around 15 minutes for the discussion and Q&A. So please share your questions in the chat box and we'll address them during the discussion section. Finally, before we close, I'll briefly share a few announcements about upcoming events. So before we begin, I'd like to start with an acknowledgement of country, a practice here in Australia where we recognize the traditional custodians of the land. So I would like to acknowledge the traditional custodians of the land from which I'm joining today, the Abakal people, the traditional custodians of the land on which the University of Newcastle's Calhan campus stands. I also recognize that many of you are joining from different lands across Australia and beyond. I pay my respect to elders, past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples. We recognize that sovereignty was never ceded. This land always was and always will be an Aboriginal land. Thank you. With that, it's my pleasure to introduce our speaker, Nilantha Randeniya. Nilantha is a doctoral researcher at the Global Disaster Resilience Center at the University of Huddersfield in the UK. This research focuses on applying artificial intelligence and advanced spatial analysis to improve climate change impact prediction, particularly in disaster risk reduction. He also pays attention to the ethical and societal implications of AI in climate modeling and how research can translate into policy and practice. Also, currently, he is a tutor at the Manchester Metropolitan University International College. On a personal note, I have known Nilantha since our university days at the University of Moroto in Sri Lanka. So it's genuinely a pleasure to introduce him today in this platform. So we are very glad to have you with us, Nilantha. Over to you.
Thank you very much, Yashoda. So thank you very much for the invitation, being a presenter in this great seminar series, and I will share my presentation. Okay. I hope you all can see my presentation. Is that true, Yashoda?
Yes, we can see.
Okay, thank you very much. So I will start with the background. To the background of this small project is my visit to Australia last January in 2025 with the Western Sydney University, and I was mentored by the Professor Srinath Pereira in Centre for Smart Construction Management in Western Sydney University, and the another two great supervisors, Dr. Krishanti Senemiratna and the Dr. Samira Vijayasiripatirana. And I would love to acknowledge my supervisors, Professor Richard Haig from University of Huddersfield and the Professor Nilantha Amratunga from Loughborough University, UK. So they are the backbones behind this project, and this project we named as integrating AI into the disaster risk reduction. And we did the snapshot study about the global review and the empirical insight from the Australia's multi-sectoral adaptation, how the AI adapted in the multi-sectors. We choose sectors as academic, educational sector, which is universities and the research institutions, and the NGOs, companies, private organizations, and the well-wishers and everyone in the disaster risk reduction and the AI sectors. So when it comes to background, why we doing it? So the first thing is we understand and we recognize that the Australia's disaster loss in 2026, it's going to be 73 billion UADs, and up to now it's 38 UADs loss due to the disasters. And after our research, we have found out that the 2.1 out of 5 adaptation score in government AI adaptation score, which is government is the main responsible organization or a responsible party of the disaster management and disaster risk reduction, where they only do around 10% or 20% of adaptation of AI. When we consider the research and the universities, we found out the 90% or 95% of academic and the AI deployment in there. So that is the main research gap we have found out. And then after we done based on that research gap, we did the systematic literature review within the Scopus and Web of Science databases, and we have found out the 2 decades of data from 1999 to 2024 December, and we have identified the around 2,000 papers, and after screening via the Prisma, we found out the 217 papers included in 2020. So our framework was a mixed method with the 60% of threshold to catch up the what are the papers we're going to decide. And when it comes to organizations, after we developed the qualitative study based on the organizational profiles, and we conduct interviews, around 25 interviews within Australia with the NGOs, government institutions such as Bureau of Meteorology, Australian Climate Services, and the NSW Water, kind of the institutions in the Australia with the disaster management profiles and everything. So it's 14 Australian organizations we have interviewed around, and also we did the document analysis as well, 41 documents, government strategies, government policies, institutional strategies, AI adaptation reports, and the regulations and everything. Then after we come up with the in vivo analysis of the coding, we emerged 8 themes and 19 sub-themes based on the other data, which is empirical research studies. The second layer is the interviews and the focus discussions. Third layer is the government document analysis from the government, and we recommended from those interviews. And when we come to the literature, we have found out that there are 3 main AI deployment stages from 1999 to 2010, which is the second AI winter season. We call it winters, where the AI was not used in mainstream studies, but undergone the development of the AI strategies and the policies. So from 1999 to 2010, based on our search index, which is DRR, AI, and the climate resilience. So we have found average 2 papers per year. Then after the second winter breaks, the second AI winter breaks, from 2011 to 2018, we have found out the moderate growth of the study area. Then after, with the introduction of the chatbots and the COVID-19 and everything happens together, from 2019 to 2024, the exponential expansion of the AI and DRR sector, around 47 to 50 papers within 1 year. So what we have found out 2024 is a last date we encountered, and there are around 60 papers per year, so which is a massive exponential growth between these sectors. So then after we found out there are implementation studies, there are some studies who look forward how the AI can be deployed. There are studies discuss about how the AI is important, kind of studies of why we need AI, how we use AI, and what we need to do via the AI. Like of studies we have found out, and we mapped them, how we can. Oh, sorry, something happened to me. Okay. Okay. All right. Then after we found out we get the AI technique, then we map out how many studies in there, what is the operational gain, what is the claim gain, and the implementation gap. So I will go through the 1 or 2 AI techniques. When it comes to random forest, 74 studies identify the random forest is a good technique for the AI in the DRR sector, and they gain the accuracy gain. It's a claim gain, means the accuracy gain of 35 to 45%. The operational actual gain, the research papers reported is 18 to 22 gain, and it's around 48 reduction of the implementation gap. When it comes to large, long and short empirical models and the RNNs, there are 49 papers, and it's claimed that the 55% of gain, but operationally it's only 12 to 18% of gain of the accuracy, which means around 70% of reduction of the accuracy. So when it comes to hybrid, which have a highest implementation gap, around 73%. So the average lab to field performance loss is around 59%. So which means the academic sector is developing a lot of AI models and the ways of doing good things, but when it go to the application level with the government sector or NGOs, so the accuracy level is getting down up to 50%. So we are developing one paper based on that, how these good enough systems cannot be adopted in the real ground situation. So then after we discuss about the sector specific AI adaptation in Australia, then we found out the government sector. I will discuss first government sector. So it gets around 18 to 20 months of procurement time, 10 times below the computation needs. Explainability is a mandate. So if we can't explain how the AI output came, if we can't explain what are the coordination within the government model, what are the what are the syntax within the model, so the government sector cannot be apply them into their day-to-day life, day-to-day work, because government need to have a validation, accountability to adapt anything what we are saying. So that is one of the main gap we have found out. So the downscale can be good, satellite usage is good, but when it comes to adaptation, we have found that the adaptation is a huge gap it around 2 to 5% of the gap within the government sector. When it comes to academic sector use a lot of AI in DRR context. Around 80% or 90% of academics are using AI to their day-to-day work. It's the same scenario with the climate and the DRR sector. When it comes to NGOs, they're moderately using AI to evaluate evolve their work and evaluate their work. So the why we thinking the academics and NGOs can be used AI greater than the government sector? It's because of the smoothness of the process and the smoothness of the regulation. So that is the main thing we have found out from this research study. Then after, we deeply learn operational barriers. So within the sectors, and what stopped the adaptation, why the things are work else in everywhere. So we have found out 89% of data volume requirement within the government, and we have found out computational demand, 78% would need 2 million AUD-DCUP clusters, and we have found out the black box problems and the transparency problems in the government sector. Legal requires explainable discussions to adapt anything. So it is the 71% of the problem within the government sector, and the training instabilities. So the government sector is kind of hard to evolve from what they have and how they're gonna evolve their trainings and stabilities. And the maintenance complexity. It is high maintenance, high cost, and the high reliable, but it comes with a greater cost. So then after, we found out some good example from the world. First example is the Germany. They have adapted AI into the flood. After the 2021 flood, they have increased the 18% of their adaptation into the 47%, around 50% of adaptation crisis as a reform catalyst, mandatory AI impact assessment. So the second example is Japan. They have increased the 5 years of Society 5 initiative from 22% to 68%, which is a good number we can see. And the Canada centralized the AI unit, cut implementation time by the 40%, and the USA with the Google flood forecasting, 78% of accuracy gain in public sector partnership with the bypass federal bottlenecks. So those are the kind of good lessons we have identified from the global context. And and then after, we have recommending 5 main recommendation. First one is National AI DRR Coordination Unit. What sort of nationally things, national, like a nation's the needs of the nations are different, and the need of the nations and the things nations are need is different. So there must be a national AI DRR coordination units, which is UK have within the UK Met Office, and they are governing everything and every need coming from the government sector, not from the academia. So the second thing is AI testing sandboxes. Third one is stage adaptation protocols. Fourth one is the standardized APIs, how we can standardize the AI with the APIs. And fifth one is a mandatory AI training. So I can share the UK experience. The UK AI adaptation is around 4% of 5. So when it like around 80% from the percentage. So when it comes to UK have a central AI ethics committee, and this central AI national AI DRR coordination unit within the Met Office. So they are governing everything much need and getting the feedback from the academia and the research units within the UK. So as a conclusion, the implementation paradox, what the academic sector is developing, it's going to the government sector, which there is the implementation paradox. The second is the technical capabilities exits, but they are trapped. So because this is a problem about not to having an AI method, it's about the problem of the adaptation and the accountability of the government sector. So the institution reforms are the solution. So the government institutions mainly need to be reformed and to adapt the new technologies. So those are the main things we are recommending via this project. So if you like to explore more our work, I would suggest these 3 papers within this context: how the responsible intelligence can be used, how the AI and climate change predictions can be used, and how the flood perceptions can be used in vulnerable communities kind of papers. And you can go ahead, kick it. And if you like to join to our work, we are now developing a world first global standard to AI ethics in climate science and disaster risk reduction. So this initiative brings researchers, practitioners, and policymakers from across the global, and we are doing it with the IEEE. We got the pass to develop the AI standard within the 7000 series. So I would love to invite you all to scan this QR code and join with us if you would like to contribute your knowledge into this standard. So thank you very much, Yashoda, for invitation.
Thank you, Nilantha, for your very interesting presentation. I hope we can start the Q&A session since we have actually enough time for the discussion. Maybe I can start with a question until the chat box is filled with our audience questions. Nilantha, in your study, it shows the government agencies has less AI adoption compared to academia, right?
Yeah.
Given that the technology clearly exceeds, and what do you think is the single most important first step Australia should take to close this gap, and who should be responsible for taking that step? Would you like to add? Yeah.
Thank you very much, Yashoda, for your question. And it's interesting. I found out within this study and within my PhD, so every government, every society have a different needs. So it's need to be reflect their need, what the government is doing. So we can, as an academic, I'm academic. I don't have a government knowledge and how the governments are works. So I don't have that knowledge. So what I can recommend is from the government sector, they need to have an assessment what side of accuracy we need to implement the AI. It's based on the need of the government sector and what sort of resources they do have. So we did study in not in this project, but in the other project, we did study in the Sri Lanka and Nepal how the government sector adapt the AI. So they are using kind of very interesting methods. They're using mobile methods, not the big data centers, not the highly developed capacities of AI, highly resource context. That's their need, that's their capability. With AI, they don't have the rich environment to invest in the high computational needs and the high quality data. So, but they are using AI as much they can. So it depends on the need. It depends on the capabilities the governments have. So that's what I'm thinking. So it's coming from the government sector and it's coming from the people of that nation. Thank you, Vishada. I hope I
Yes,
answered.
yes, that's clear. And we have another question in the chat box from Hopkins. Uh, this question is, to what extent is the low adoption rate of AI caused by limited availability to reliable data, or is merely a cultural thing? Uh, could you, yeah,
Yeah, I thank you very much for that question. I think it's a cultural thing, uh, because it's a bit tricky question. It can be a cultural thing and it can be a limited availability. So when it comes to Australia, we found out it's a cultural thing. We found that it's a regulation barrier. So the when we ask some of the government officials who is working in the top ranks of the DRR agencies of the government, and we asked one question. We had one question called, do you have ethical framework? Do you have ethical committee within your organization? They ask what? Do we need ethical committee kind of thing? So if they have any output, it's not going through the validation process. So I guess it's a sort of a cultural thing when it comes to Australia. But when it comes to other countries, as I mentioned, Sri Lanka or Nepal, it's a limited resources. I guess it's a cultural and the limited resources as well. So it's a two-way questions. Either
yes.
ways, it can be happen.
Do you think the policies should be there to implement these kind of things? Is it another? Can you identify policy constraints as a one barrier to implementing AI technologies in this context?
Yeah. I agree with you. It's a one of the barrier of the policy constraint. If there is no policy, someone can implement the AI within the government if they have a good leadership, but it is not the sustainable development. It's not the sustainable implementation, I guess. So the next regime, next person can change it if there's no policies. So that's why the AI implementation in government sector is low, because they doesn't have a policies. When they develop the policy, the AI goes to the next steps. So it's developing rapidly. It's going rapidly. So that's the problem within the AI and the government sector. So the government have to act quickly to capture the knowledge.
Yeah, that's great. I want to come again to your recommendations as well. You have proposed as a recommendation like establishing a national AIDR or coordination unit. You there you have followed the Canada's approach, right? Right? Uh, could you explain how such unit would like operate in practice, like for the what types of AI applications it would coordinate across the current disaster management practices? Yes, when you tell there are different AI applications, but how that link to the DRR practices?
Yeah, thank you very much. Actually, so I can more talk about the UK practice, because I learned about the UK practice more than Canada. So this particular paper we included Canada because it's before I learned the UK practice. So that's why. So when it comes to UK practice, they do have a unit within the UK Met Office to govern the AI outputs and the outputs from the UK Met Office. So that's the main body, and every output going through that body. So and first thing is that. Second one is they are what they do is they are regulating what is the outputs are come. The second thing is they are designing the next stages. So that is the main thing. So they can design with the global need and the global recommendations to the next stage. So that is the main two things this AI DRR coordination unit must do and have to do. I guess I answered.
Yeah. Oh, great. Udangani has raised her hand, so
Yes,
you
Yashoda,
can.
can I ask?
Yes.
Yeah,
Go ahead.
okay. Thank you, Nilantha, and good to see you again online.
Thank you very much for you.
Nilantha, now for your study, did you use a particular kind of a definition for AI? Because um, some people might even take small technology adoptions as AI, right? So, on what basis you defined this AI? Did you had a
Yeah.
kind of a working definition to identify what is meant by AI for this particular study?
So we use the AI techniques. We have identified the 7 AI techniques mostly used in the. First of all, thank you very much, Professor, for your question. And what I need to explain is we did use 7 main AI techniques, which is mostly adapted within the DRR sector. First one is a random forest. Second one is a gradient boosting. Third one is the CNNs. Likewise, we have found out 7 AI techniques, which is adopted, which is used in DRR sector. So those are the 7 main AI techniques we use to search the extent of usage. So not the entire context of AI, not the everything within the AI. So we have filtered 7 main AI techniques, and we look how those 7 AI techniques are used within the government sector. And yeah, so that's basically what we done.
Yeah.
Thanks, Nilantha.
Great. We have another few questions in the chat box. I think we can. I'll read one of them. Okay, we have question from Temi. In what ways can the DRR sector strengthen the data governance, such as data sharing, quality assurance, and privacy safeguards to fully leverage AI without compromising public trust? Nilantha, what would you like to add to this?
Yeah, thank you very much, Temi, for this question. I guess it's come up with the ethical and accountability frameworks within the government sector. So when it comes to DRR projections or the climate, when it comes to climate projections or climate predictions for the next 100 years of time, so it's use lot of data, massive set of data for those type of projections. So when it comes to DRR, like risk assessments as well, that agency must use massive set of data for that projection. So when it comes to the output publications and the data sharing, so that particular organization must follow the data sharing policy or data protection policy within the government. And when it comes to use of AI, they must use it in responsible AI and the ethical AI principles. There are ORCID ethical AI. We can adopt the ORCID ethical AI principles. We can adopt the UN DRR AI ethical principles. UK is adopted the European Union's AI ethical principles. So every country can, and also UN do have AI ethical principles as well. So if one country doesn't have their own AI ethical principles, so they can adapt what the UN is developed. If they don't like to adopt UN's, so they can adapt the regional ethical AI principles, like UK adapt the EU. And I guess Australia have a AI ethical principle, and data protection policy as well. So they must have those type of regulatory foundation before implementation of the AI. Otherwise, its output's gonna have no way, like it's a one-way direction talk other than two-way directions.
Yeah, great. Let's we have another. I saw there was another question in the chat box. I can't find it now. Give me one sec. Yes, it's from Yongki. I believe I pronounced your name correctly. The question is, have you done any measurement of the positive impact of implementing AI in the context of disaster management? Nilantha, would you like to add something?
Yeah, thank you very much for that question. Yeah, we have measured how the accuracy rates are going up with the implementation of AI into the DRR projections and the climate projections. So I will share the numbers with that. So in Japan, before AI adaptation, so the output accuracy was 22%. So which is they done how this accuracy measure is they're gonna do guess that the 1990-50 they're gonna predict the accuracy up to 2020. So then they calculate and measure and what it says, they measure the gap between that prediction. So then after they do without AI, with AI, and they measure the accuracy levels based on that. So Japan have done it. So their first accuracy with the statistical and numerical model, it's a 22% of the accuracy from the 100, and with AI adaptation, it's gained up to 68% of accuracy. So that's the number of the accuracy increase. So Germany also done it. It's 18% of the numerical and statistical, the physics-based models. With the AI development, with the AI adaptation, it's raised up to 50% of the accuracy. So personally, we didn't do that with our own. We did identify it from the papers and the available resources.
Yeah, great. If you have, I think, yes, if you have any questions, please feel free to put it in the chat box, or you can raise your hand and just involve in the discussion. Okay, I have another question. Give me one sec. I wanted to ask one question about your National AI DRR Coordination Unit again, right? You showed few examples from different countries like Japan, Germany, and Canada, where AI adoption increased significantly. But you're suggesting the Canadian model over the other international model. Is there any specific reason for this one? Is it because of it is a centralized system or something? Is there any specific reason? I just asked. Yeah.
Actually, the main thing is, thank you, Ashoda. Main thing is, like as models, we can't adopt other countries' models. Like there are a concept called AI sovereignty. So if we adopt other countries' model as it is, it's gonna affect to the country's sovereignty or something like that. So it need to be redeveloped based on the country's need. So that's the main thing. So if Australia need to adapt UK system, they need to adapt it with the with the additions and the adding some more dimensions to that particular model. So it's same with the Canadian model as well. So if someone need to adapt the Canadian model, so it need to go with the additions and additions of the what the country must provide within the because it comes with the indigenous knowledge. Australia can integrate the indigenous knowledge, which is the kind of a positive thing, and how the diversity of Australian diversity, where the Western Australia is different than the Sydney and the Brisbane and everywhere. So it's need to be adapt the with the additions and adding new perspectives to the those models. It's not the entire model replacing one thing from another.
Yeah, great. I think it seems like we don't have any more questions from the audience. I'll ask one final question. This is about okay. Yes, Professor, you can
Yes,
ask
can I
question.
ask another question, Nilantha? Because
Sure,
we are also about to start a project in AI, DRR, and making resilient cities. So going beyond the broader perspective of AI techniques, can you identify any particular applications that have been used either in Australia or in during your study? Have you come across any particular applications that has been used for AI and DRR? Say, for example, it could be something like crowdsourcing using AI. So if you can name anything like that, just for the interest of us.
Yeah. So thank you very much, Professor. So when I discussed this with one of my colleagues in Japan, and he shows one of app where the safe place. I think we can't I can't access to that app without within in the UK, but it's called the safe space when there's any sort of a disaster happening in Japan or anywhere within Japan. When, as example, you think about the Tokyo, if that person in Tokyo, so the massive earthquake happens or the massive tsunami happens, so that app shows where that person need to evacuate, the safe place of the evacuation routes and things. So that app was kind of a great initiative, great application with the AI and DRR and the city planning perspective as well. So that app shares everything. So you have to go there, and that road you have to get the right turn kind of thing, and we can choose the mode of via transportation. Are we transport by the car or public transport, or we're going to go by foot? So that we can put it to that app, and that a kind of interesting app, so that we can find out the safe place when something happens to the city, or like that. Now they are developing it into the sort of a war as well. So how, if there's anything war or any blast or happens, so how they can evacuate from that particular station to the safest place of the city. So yeah, that's a kind of, I think its name is a safe place. I guess it's in a Japanese language. I don't know what's the, but I can send it to you, Professor. So I have I take a photo of his app from his phone. So I have that photo. So I will send it to you. Thank you very much for that question.
Thank you, Nilantha.
Okay. Then as one final question, I'll ask, you mentioned the rapid growth of AI research in disaster risk reduction, and you showed in your presentation. So where do you see the most impactful applications emerging in the next few years, if you think about the future out of this.
Yeah, so actually, I mentioned it's after the 2019 with the introduction of the chatbots, the ChatGPT and Claude and those type of chatbots, and now they are evolved to, I guess, plan wars. So that's the main thing we have identified. So the next, so this is the one of the phase with the chatbot with the exponential growth, and now they are in a maximum level, I guess, after another 10 years. So after that, now the world is going forward to the Gen AI, so how the generative AI is working. So I guess the next era of AI is Gen AI. So we came from the first AI winter, where the nearest neighbor tools are happen. Then after second AI winter, we found out the random forest and the programming languages and things. Then after, now we are in a chatbot and that era. Then after we will go for, I guess, we will go for a generative AI, where the robotics and the things happens in our future. So I don't think we will find out another AI. Winter means AI doesn't walk within the general public. I don't think we will happen to have that era again. And I have heard Japan is developing a robot for one, like a buddy robot. So every person, everyone have a mobile phone, everyone have a laptop now. So like that, everyone must have robot. So that's sort of a thinking. It's happening within the world, how the world is developing and how the things are getting evolved. So I can't guess what happens in another 10 years, but I can say how the others are thinking about the AI. So others are thinking about everyone need a robot, like a buddy robot. Like I have a phone, so I will have a robot within another 10 years.
Great. Thank you very much for this insights and all the things. And we have an announcement from we have an announcement from Hub cases. It's about Hub. Do you want to give more details about the task group meeting to our audience? Since we have time,
I just wanted to make a little bit of advertisement for another task group within CIB. It's specifically on AI. But hearing the story from Nilantha earlier today, this morning or evening, it would be great to share this also to a little bit bigger community. And maybe on top of that, one of the things that we're looking in is really use cases. You touched on a lot of use cases, actually, Nilantha. But I'm also having a question, if I still may, we still have a few minutes. You were discussing academia, you were discussing the governments, but actually one where it should accelerate even more is the construction industry, I would say. So did you touch upon that one as well during your research? And once again, everybody interested, please join task group 126. It's in the chat.
Thank you. Thank you for that one as well. Okay, then I also have a few announcements about our future events. Yes. First, our next W120 Commission meeting will be held on 31st of March at the same time as today. And we warmly invite all of you to join the meeting, as we'll be discussing upcoming Commission activities and our plans for the coming years. Also, our next W120 seminar is coming up on 21st of April. The seminar title is Resilience Recovery After Disasters, Learnings from Post-Disaster Housing Reconstructions over 3 decades in Asia. So the session will be delivered by Dr. Mithul from RMIT University. So should be a very interesting discussion. I invite all of you to join that session as well. So now time to wrap up the session. Thank you again to our speaker Nilantha for such an insightful presentation. And thank you everyone for your participation and engagement today. We truly appreciate your time. Thank you everyone. Goodbye.